Today we're gonna do acids and bases and neutralization and salts. In this video I'm just gonna cover acids and bases, and then once we get that down we can cover neutralization and salts in another video. So yeah, let's get straight into it. So first things first, we gotta define what are acids. What are acids? You might say acids, oh, basically they are like burn. It's like you touch it, then you like your hand will like melt or something. I don't know, you give like a weird answer. No, you must give the scientific answer, which is a substance. A substance that what? Everything is a substance, right? A substance that dissolves. Dissolves in what? Dissolves in water. Okay, so it dissolves in water, then what does it do? It produces hydrogen ions. So to produce hydrogen ions. Okay, so we got that down. A substance that dissolves in water to produce hydrogen ions. So what? Okay, let's dissect the hydrogen ions. Okay, so these hydrogen ions, right? The hydrogen ions are responsible for the acidic properties of acid. Acidic properties. So they basically make what? They basically make a substance an acid. So you would say that something without a hydrogen ion would not be an acid. Okay, to see if it's true, we look at the chemical formulas of four different types of acid that we four different types of acid. So there's the famous one, which is hydrochloric acid, and then there's nitric acid, and there's sulfuric acid, which is my favorite because I like the way like sulfur becomes sulfuric. I like the word sulfuric, it sounds cool. And one last one, ethanoic. Okay, so these four acids, it is part of syllabus for us to remember the chemical formulas. So I'm gonna teach you how to remember. Okay, hydrochloric. Hydro comes from the word hydrogen. Chloric comes from the word chloride. So hydrogen chloride, so therefore the chemical formula would be H for hydrogen and Cl for chloride, the chloride ion. Okay, then for nitric acid, nitric comes from the word nitrate, which I covered in my previous few videos. So what is the what was a nitrate? What's the chemical formula for a nitrate ion? It is NO3 minus. Okay, so this minus is important because then we need to know the number of hydrogen atoms we need. So hydrogen, it has a charge of 1 plus. Oh wait, it has a charge of 1 plus. So how many pluses do we need to cancel out the minus? We only need 1, right? So therefore we only need 1 hydrogen. HNO3. So that is the chemical formula for nitric acid. Sulfuric acid, on the other hand, it's kind of the same steps but a bit different. So sulfuric comes from the word sulfate, which I also covered in one of my previous videos. Okay, so what's the chemical formula for sulfate ion? It is SO4 2 minus. So the charge is 2 minus, and the charge for one hydrogen is H plus. The charge for one hydrogen is plus. So therefore, we need 2 hydrogen to cancel out the negative, the 2 minus. So H2SO4. Then just minus the 2 plus, 2 minus. Okay. Ethanoic acid. Ethanoic, we have to use a bit of organic chemistry knowledge. Okay, so let's dissect. Eth stands for the prefix eth stands for two carbon atoms. Noic is the suffix for what? Wait, what? What? So oic acid is for carboxylic acid. So what is the general formula for carboxylic acids? Okay, let me check because I got it wrong for the other video. Okay, carboxylic acids. CN H2N plus 1 COOH. Right? Yeah. Okay. So since there's 2 carbon, N will be 2 in this case. So we just apply the formula. So the chemical formula for ethanoic acid would be C2 2 times 2 is 4 plus 1 is 5, so H5 COOH. Let me check if that's right. No, it's not right. I'm wrong again. Okay, hold on. No, turn on that. Okay, let's see why I'm wrong. Ethanoic acid. Okay. I got it. So you have to take note that there's one C and another C over here. And since F is for 2 C's, we already have 1 and 2. We already have 2 C's. So N is not equals to 2. N equals to 1. Okay. So N equals 1. So therefore, the chemical formula would be CH 1 times 2 is 2 plus 1 CH3 COOH, and that is right because I checked answer. Yeah. So these are the chemical formulas that you need to remember because they are part of the syllabus. Okay. So I guess that's kind of the introduction for okay, hold on. Okay. hold on, let me pause. Okay, yeah, that is the introduction. So now we will learn more about the chemical properties of an acid, or mainly the, should I erase it? Maybe not, maybe I shouldn't. Oh, never mind, I should just erase it. Okay, mainly about the reactions that occur among acids. Okay, by the end of this video, this question mark should not be here, because you would have understood acid by now. Okay, so the first chemical property of an acid chemical property number 1, it would be okay, the first chemical property would be between an acid and a metal. Okay, so an acid and a metal, they would react together to form salt and hydrogen. Okay, so let's use I'll give you an example. Let's try HCl plus magnesium metal. Oh, okay. Let's include state symbols: aqueous and solid magnesium. Okay, so the salt would then be, okay, before that, let's take a look at the elements or the atoms that are in this reaction. So we have hydrogen, we have chlorine, and we have magnesium. Okay, so therefore the reactants, the elements or the atoms that are in the reactants can only either be hydrogen, chlorine, or magnesium. Only these three elements can appear, nothing else and nothing less. Okay, so you have to make sure that all three elements can be found on this side of the reaction also. Okay, okay, so then the salt would be, okay, let's try a bit of logical inference. So hydrogen and chloride, they are together, right? And then they react with magnesium. Do you think that the hydrogen and chloride would still be together after the reaction, or would they be separate by now? And same thing for magnesium. Before the reaction, magnesium is alone, but after the reaction, do you think magnesium would be alone, or do you think magnesium would have found a partner? So obviously, if everything stays the same, if hydrogen and chlorine are still together and magnesium is alone, then there would be nothing special about this reaction lah. I would say that actually this wouldn't even be a reaction. Yeah, so after the reaction, the salt that would be formed would be magnesium chloride. Okay, magnesium chloride. Now we have to look if it's balanced. Okay, so magnesium is over here, which means it has a charge of 2 plus, and then chlorine is over here, which means it has a charge of -1. So 1 chlorine will not be enough to to match up with a magnesium. Therefore it needs 2 chlorine. So we need 2 chlorine over here, and then so that substance, magnesium chloride, would be an aqueous substance. All hold on, let me check if it's right. Yeah, most chlorides are soluble except for lead and silver, lead 2 and silver. So magnesium chloride is soluble. So since it's soluble, it would then be aqueous. And we have hydrogen, H2, because hydrogen is part of a group of gases, diatomic elements. So hydrogen is part of these diatomic elements which exist in pairs. That means there are two atoms. These two atoms are always together, and they are basically always together lah. So it will always be something 2, O2, N2 or H2. Okay, then then pay attention over here, Cl2 and H2. But then over here, there's only one H and one Cl. So to balance the equation, we need to put a 2 HCl. And then magnesium, it doesn't change. The number of magnesium doesn't change. It's always one magnesium. And as such, we have a proper chemical property now. Okay, so while doing the equation, I realized that I skipped quite a few stuff. Okay, I will now that you know what how to do this chemical property, you know what, I'm just gonna never mind. If you did not understand like 90% of that, never mind, because I'm gonna teach you right now. Remember the 4 acids that we have just now? We have hydrochloric, we have nitric, that's M, we have sulfuric, and ethanoic. For this part, let's just ignore ethanoic, because I've never had an exam question where they test this about ethanoic. So as seen over here, acid plus something will give you a salt, right? A salt. So how do we know the name of the salt? Well, there's a specific set of rules that we follow, which is basically, if hydrochloric reacts with something, the salt of that will be something chloride. Nope, that's wrong. Chloride. So if I react magnesium with hydrochloric acid, then will be magnesium chloride. If I reacted it with, if zinc reacts with hydrochloric acid, it will be zinc chloride. You know what I mean? So it's just the name of the reactant. For nitric, it would be something nitrate. That's what's an example? Magnesium also. Magnesium nitrate is also another example. And and so for sulfuric, it's kind of the same thing. Something sulfate. We can have sodium sulfate. Again, sodium. For this one, it can be sodium chloride, which is salt. Your literal table salt, the one that you use in cooking. Sodium chloride. And yeah, that's how you get the name of the salt. Should I um okay, you know what, I'll post another video for writing balanced chemical equations, because you need to like know how to write balanced chemical equations to understand this whole chapter. But I haven't taught you guys yet, so so yeah, yeah. If you don't understand writing balanced chemical equations as of now, I think by the time I upload this video, the video on balancing chemical equations should be out now. So I'll just assume that whoever's watching this, you know how to write balanced chemical equations. Alright, so that's one example of an acid and metal. Okay. Okay, yeah, I forgot to mention chemical property number 1. It has one exception. Must take note of this. It is very important. Okay, that exception is copper, gold, and silver. These three elements do not react with acids. So why don't these three elements react with acids? Okay, let me just label in case you guys don't know. So Au is gold and Ag is silver. So the reason why these three metals do not react with acids is because in the chapter metals we learn about the reactivity series, right? So in the reactivity series, these three elements are the elements that are lowest on the reactivity scale. So these three elements they do not react with anything. They are so unreactive that if you add acid to them, nothing happens. So therefore these three elements do not react with acids. And if they test a question something like this, like copper and an acid, it is most likely a trick question. Yeah. Okay, so that is chemical property number 1. Oh, and how do you remember this chemical property? You just put it in like a short form. So A plus M gives you S and H. I should change this. It doesn't really. Okay. Or should I keep it? You know what? Make the plus smaller. Oh my gosh. Okay. So A plus M gives you S and H. So that's the easiest way to remember lah. You shorten it. Okay. Chemical property number 2. Okay, chemical property number 2. Acids react with what? Acids react with carbonate. Okay, acids react with carbonate to give you what? Give you salt, carbon, your favorite gas, carbon dioxide, and your favorite liquid. Your favorite liquid, which is water. If you say any other liquid, you're wrong. It's water. Water is your favorite liquid. Okay. What is a carbonate? right? So basically a carbonate is something that ends with a carbonate. I'm not joking. So carbonate is basically anything with it's basically this and carbonate. So that is a carbonate. Okay, for this example, let's choose calcium carbonate. Calcium carbonate is the table salt. Table salt is your chalk in, how do I, okay, is that, yeah, okay, is that the same color? No, that's a bit darker. Okay, let's try this. Is that the same color? Yes, that's the same color. Wait, is it? No, that's not the same color. Okay, let's try the swatch. The color picker. No, I want it. No, color picker. I want this color. Yes, I want that. Done. Is that the same color? No, that's not the. That's the. What? I want this color. How do I? You know what? Okay, off topic. Okay, calcium carbonate is chalk, the chalk that you use on the blackboard. So let's write a chemical equation for this reaction. So what acid shall we use? Oh, you know what? Oh yeah, okay. Let's use nitric acid. Nitric acid is HNO3. Wait, we need to leave some space in case we need to balance things out. Okay, HNO3, and then it's aqueous because it's dissolved in water, so it's aqueous. And then let's use calcium carbonate. Carbonate, it's CO3 2 minus. So let's look at the charge for calcium. Calcium is over here, so it's a charge of 2 plus. So that's perfect because now we only need 1 calcium. Okay, so CaCO3, and that will give us, okay, it's the same thing as before. The products have to be reshuffled. If the products are still with the same partners, then that's not chemistry, because chemistry is a study of change, right? So if they don't change, then it's not a reaction. So H cannot be with NO3 and Ca cannot be with CO3. So we have to switch it up. So the salt will be calcium nitrate. Calcium nitrate. So calcium is 2 plus, right? And then NO3 is minus. So we need one more of an NO3. So to do that, we do this. NO3, and close bracket, a 2 over here, to show that the 2 goes to the NO and not the Ca. Alright, so that's our salt done. So now we have to do carbon dioxide. Carbon dioxide is a very simple formula. It's CO. Oh wait, we need state symbols. State symbols is an aqueous because all nitrates are soluble. And then CO2 gas. Carbon dioxide is a gas, that's pretty obvious. And water. Water is H2O and it's a liquid. That is very obvious. Okay, now we need to check if it's all balanced. Okay, let's look at the number of calcium. There's 1 calcium and there's 1 calcium over here, so that's perfect. And then there's 2 NO3s. There's 2 NO3s. Here we only have 1 NO3, right? Okay. Then we have CO2. Here we have CO3. So let's just stick. And then we have cancel, we have one oxygen left. So here we have 2 hydrogen and 1 oxygen, and that's perfect because one more cancel, and then we have our oxygen. We have the same number of oxygen on both sides, and then here we only have 1 hydrogen. So we are missing 1 hydrogen and 1 NO3. This is a simple fix because to balance this equation, all we need to do is just a 2 at the front, 2HNO3, and there we have it. That is our chemical equation for chemical property number 2, acid property number 2. Yeah. Okay. How do I remember this equation? It's again I shorten it. A plus C. Oh, but this time I like to add the chemical formula. A plus CO3 gives you a salt plus CO2, because that's simple to remember, and water. I put W because it's shorter than having to put H2O. Okay, so that's chemical property number 2. Let's go to chemical property number 3, which is the last one. How long has this been? 31 minutes only. Alright. Wait, oh no, I have to cover bases also. That means this video will probably be an hour long. Okay, chemical property number 3. It's called neutralization. It has a name. Neutralization. This chemical property is quite unique because it has a name, whereas for the other 2 chemical properties it does not have a name, or at least in the textbook it doesn't specify the name lah. Okay, so the I'll just teach you this first. So this chemical reaction is between an acid and a metal oxide or a metal hydroxide. So it's either oxide or hydroxide. And that will give you a salt, and your favorite liquid, water. I hope you said water because I mentioned that water should be your favorite liquid. Okay. So what is a metal oxide? Again, similar to a carbonate. It's basically a metal, and then at the end it has the word oxide. Okay. What's an example? Okay. An example of a metal oxide would be aluminium oxide. Aluminium oxide, it is under a group of oxides which I will touch onto later, but I'll just name drop. It's amphoteric. It's an amphoteric metal oxide. And so that's for oxide. How about hydroxide? We can use calcium again. Why not? Calcium oxide. No, hydroxide. Sorry. Hydroxide. So these are examples of metal oxides and hydroxides. Let's use aluminium because we already use aluminium oxide. Let's use aluminium oxide because we already used calcium just now. Okay. What acid shall we go with? Have you done sulfuric acid? Oh, you know what? Okay, I'm too lazy to do any work right now, so I'm just gonna use the examples in my notebook that we did in class. Okay. Another example of a metal oxide would be tin. tin 2 oxide. Tin 2 oxide. Okay. And now let's use sulfuric acid. Okay. H2SO4 equals, okay, tin 2. Oh wait, tin is here, Ti for tin, and it's a in this group of metals, right? So this group of metals will be called transition elements. So in transition elements, other than silver and zinc, they will give us the charge of the metal. So tin 2 tin 2 means to have tin and a charge of 2 plus. So metal oxide is basically O2, right? Yeah, it's O2. Okay. No. Oxide isn't O2. Oxygen is O2. I'm tripping. Okay. So, oh, I just did. Okay. Where is O? O is over here. And O has a charge of -2, since it's in this group, right? So it's a charge of -2. And that would be perfect because -2 and +2, they balance out so that it becomes 0, and that's good because I don't know. Tio. Okay, metal oxides and metal hydroxides, they will always be aqueous form. Why? I will touch on that later. Under bases. Okay, H2SO4 and TiO, they form a salt and water. Okay, they have to mix around, you have to rearrange them. So H2 and SO4 won't be together, Ti and O won't be together, so it will thus be called that the salt will then be TiSO4, and it works out because Ti has a charge of 2 plus, SO4 2 minus, so then it will cancel out and become 0. Don't ask me why we like 0, because I don't know. TiSO4, there's a salt, and then we get water also. We have okay, let's check if it's soluble. Sulfates, barium, calcium and lead are insoluble, so this is tin, not barium, calcium or lead, so thus this should be aqueous. And then we have water, H2O, liquid. And there you have it. Chemical reaction number 3. I deleted a lot, man. What happened? Chemical property number 3, also called a neutralization. Okay, so as you can see, something I want to highlight, right, is chemical property number 1 and number 2. Both reactions, they create should I? No, okay, that'll be later. Both chemical property number 1 and chemical property number 2, they release a gas. So for chemical property number 1, it's hydrogen. For chemical property number 2, it's carbon dioxide. So in some cases, the examiners will ask, how can we differentiate whether it's chemical property number 1 or chemical property number 2. Oh my god. Okay, so the good thing is that one produces hydrogen and one produces carbon dioxide. So to differentiate these two chemical properties, we're gonna have to test for gas. So this is where qualitative analysis comes in. This is where you would have to remember and memorize your qualitative analysis table. And because this time they won't give you, they will only give you the table in practical exams. So this is why it's important for you to remember. Okay. Oh, hold on. Okay, so to test for hydrogen, test for hydrogen. Okay, to test for hydrogen, you place a something splint at the mouth of the test tube. Okay, this second line is optional, but I put it lah just in case like they are like picky about the marks or anything. Okay, so we have two options. It's either place a lighted splint or a glowing splint. Which one is it? I'll give you 5 seconds to answer. 1, 2, 3, 4, 5, 6. Okay, I give you 6 seconds, so you should be able to answer by now. The answer would be a lighted splint, not a glowing splint. A glowing splint is only for oxygen. A lighted splint is for hydrogen. Okay, so now that you've placed a lighted splint at the mouth of the test tube, what will happen? How do you know if it's a hydrogen? You can just put a lighted splint and then you say, okay, that's done, it's hydrogen. No, you need an indicator. You need something to happen to tell you that it's hydrogen. And the thing that happens is a pop sound. These are like in like what is it called? Apostrophes. Yeah. Okay, the good thing about this test, right, if you do it during your practical, oh, hold on, I'm not done. And okay, the good thing about this test, if you do it in practical, right, is there should at least statistically there should at least be one person in the same lab as you that will have a pop that is so loud. Okay, so that pop, if you hear that pop, it is basically free giveaway marks for you, because it's basically like you're basically cheating. You know that, oh, okay, so there's definitely hydrogen in the test, and then now you can like you can write your observations and then you'll get free marks. Sometimes you won't even need to do it, right? You won't even need to do the test to figure out, because the other person already did the test for you, right? However, if you are if if you want to mess with people, you know what I would do? So they will for chemistry labs, I don't know if they do it for O levels. I haven't done O levels. I don't know. Okay, but for prelims and mid years, they don't clear out the chemistry the tables. So that means there are bottles of acid at the front, right? And then there's also a bottle of magnesium strips in one of like the corners lah, or like I don't know what is it called, the plastic holders thing. Okay, basically you get a test tube, you add any acid. I recommend like hydrochloric or something lah, hydrochloric acid. Then you add, oh, it's either magnesium strips or aluminium foil. So you just add I would suggest magnesium strips. You just add magnesium strips, and then you do this test, and then hydrogen, cause we learned that in chemical property number 1, hydrochloric acid and metal, which is the magnesium. It will give you hydrogen, right? So you can just make a fake hydrogen test. And by making a fake hydrogen test, you're basically testing for hydrogen, and you're like it, and if your pop is loud enough, you can trick others into hearing a pop sound. You get what I mean? So if you finish the paper early, then you can do that, and then you can trick others into thinking that there's actually a pop test in this practical, and then you can like trick others into doing extra work or whatever, which I highly do not recommend unless you have really nothing better to do. Okay, so that's test for hydrogen. Let's do test for CO2. Okay, test for CO2. We have no more space already. I think this is good enough lah. To test it into CO2, you bubble the gas. Bubble the gas into a liquid. Into a substance. What is that substance? 5 seconds to answer. 5, 4, 3, 2, 1. You bubble it into lime water. What is the chemical formula for lime water? I gave you 10 seconds to answer. 10, 4, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, the chemical formula for lime water is calcium hydroxide. I do not know if that's true. It's either calcium hydroxide or calcium oxide. Let me check. Let me Google. Lime water formula. CaOH2. Maybe I was wrong. It's CaOH2. Apparently. OMG. I just got a message, and it is my friend asked their crush out for prom, and then I asked how did it go. Then she replied, haha, that's so funny. Do you guys know, have you guys asked anyone out for prom? Let me know down in the comments. Okay, back to chemistry. The chemistry between two people. Okay, so you bubble the gas into lime water. Then what happens? What tells you that it is carbon dioxide? Well, a white precipitate, which we will put into short forms. In practical, you can put in short form. However, if it's your paper 3, you cannot put short form. You must spell it out. So precipitate, like Andrew Tate. Precipitate. White PPT will form, and that's it. That's how you test for hydrogen and carbon dioxide. Okay. Now let's go on to bases. Okay, let me pause. I'm gonna take like a 2-minute break. Okay, I am back, and we have I forgot to mention, we have officially finished wait, have you finished? Yeah, okay. We have officially finished acids. Now actually I wouldn't say we finished acids, but we finished the concept of no. Okay, you know what? Let's just move on to bases, okay? Acids and bases, right? So let's move on to acids and bases. We will revisit acids later in the chapter, but it's gonna be like okay, let's just go to bases. Okay. What are bases? Bases are basically metal oxides or metal hydroxides. The end. Okay, let me give you some examples. What metal do you all like? Okay, I'm getting a sense that you guys like sodium, copper 2, and aluminium. Okay, come let me give you some examples. Okay, sodium oxide. That is an example of a metal oxide. Now let me give you the chemical formula. That is Na2O. Why? Okay. O has a charge of -2, right? And Na has a charge of +1 or 1 positive. So +1, -2. So to make it equal to 0, we need 2 of sodium. So we need another +1. So +1 +1 -2 give you 0. That's why it's Na2O. Okay, I'm going a bit faster because you should understand by now. Okay, what about copper 2 oxide? Copper 2 oxide is basically you see here it has a charge of 2 plus because it's a transition element, and I already give you the charge. It's in the name. So it's CuO because 2 minus 2 plus, so it's equals to 0. Okay, last one, a bit harder. Aluminium hydroxide. Who's messaging me? Oh my god. It's the prom case. Apparently someone had asked the guy out for prom before my friend. But I'm laughing because it's funny. Because they are more like friends. You get what I mean? Like they're friends and they are not really dating, but the person that asked second is like okay. So aluminium. Okay, aluminium let's see, is it a transition element or does it have its own charge? Oh, okay, aluminium is over here. So therefore it's in the 3 plus. So aluminium has a charge of 3 plus. And then hydroxide, the chemical formula for hydroxide we learned is OH, and then there's a minus because I covered that in a previous video. So OH minus. Then only one minus is not enough, so we need another minus. Oh wait, that's not enough. Then we need another minus. So in total we need 3 minuses. So therefore we need 3 of OH. And now pay attention. Why can't I just put 3 over here? Because if I put 3 over here, that will only mean that I have 3 hydrogen. And I don't want 3 hydrogen. I want 3 oxide. I want 3 OH. So by putting brackets, the 3 would go over here. When I put brackets, right, it's like, you know, mathematics. Yes, I know it's chemistry. Okay. Yes, I know it's chemistry. Okay. So the 3 goes here, and then another. So 3 goes here, and then another 3. So 3O and 3H. You get what I mean? Yeah. So there's a little math required, but that's fine because math doesn't scare us, right? Right? We can do it, right? Okay. Okay. So that is the chemical formula. Wait. Okay. Okay. So under bases, there's another subgroup. Okay. You would have probably heard of an alkali. What are alkali? Okay, alkali is basically a base that is soluble in what? Guess what? If you said water, that's right. Because water is your favorite liquid, guys. Do not neglect water. Okay. So it may be hard to understand, but let me draw a Venn diagram. Because when I was starting out, it was hard for me to understand also. So this big sphere, this is base. This is everything under base. Alright? And over here, this is alkali. Yeah. So by that logic, I can say that all alkalis are bases, but not all bases are alkali. Okay. And one more thing about alkali, right? Similar to acids, when they dissolve in water, instead of hydrogen ions, this time is hydroxide ions. Hydroxide ions are produced. So some examples of alkalis are again sodium, but this time it's sodium hydroxide. And then there's also calcium hydroxide. Calcium hydroxide. Okay, chemical formulas easy. Na minus because it's in group 1. OH plus, it should be plus. Na plus, OH minus. So it's done. It's balanced. Okay, Ca 2 plus, OH minus. So we need 2OH. 2OH, we put the bracket. Cannot just put the 2 over there. And then it's done. Okay, now for the hardest one yet. Ammonia. Now I taught this in a previous video. Ammonia is the younger version of ammonium. And what is ammonium? Ammonium is NH4. But ammonia is NH. What am I doing? NH3. And does it have a charge? No. However, ammonium is NH4. Does ammonium have a charge? Yes. Ammonium has a charge of -1. Okay. I won't go much into detail for ammonium. You have to watch my other video and give me more views. I'm just kidding. But you still have to watch the other video. I'm not going through that today. I don't have much time. Okay. So, let's go to the chemical properties of alkalis. So, chemical property number 1. You're gonna be very surprised when I say it. Chemical property number 1 is gonna be neutralization. The S. Neutralization. Okay. This time, it's very simple. Why? Because it's alkali plus acid. And what does that give you? Salt and Oh, salt and water. How do I remember this? A plus A give you S plus W. A something W. Uh uh sangat sangat what's a Malay word that starts with W? Okay, never mind. Skip. Okay. What is an alkali? Lie. Okay. One example. Sodium hydroxide. Why not? Okay. What am I doing? Why I write the word? Sodium hydroxide and hydrochloric acid. Let's go. NaOH plus HCl. That will give you literal salt because it's NaCl. NaCl is your table salt plus H2O. Okay. Oh yeah, the state symbols. So aqueous is NaCl aqueous. Let's check. Most chlorides are soluble, so this is aqueous. Wait, yeah, lead 2 and silver are not soluble, and this is liquid. Okay, that is for neutralization. Should I? No, I don't do one more example because I already went through neutralization just now. Okay. Chemical property number 2. Chemical property number 2. It doesn't have a name. Okay, so it's again alkali plus what? This time it's ammonium salt. Ammonium salts will give you ammonia. They will give you ammonia in the form of gas, so it's ammonia gas. And salt and water, your favorite liquid. Okay, what is an ammonium salt? It's basically anything that has ammonia in its name. OMG. Okay, what are the 4 ammonium salts that they will most likely give? It is ammonium salts, right? They are ammonium chloride. The double stroke is basically like copy paste. Ammonium carbonate, ammonium nitrate, and ammonium sulfate. Okay, chemical formula as per usual. Ammonium is NH4 minus. NH4 minus. Okay, and chloride, it is Cl minus. Is it? Wait. Oh no. Wait, is it? Hold on. Wait, let me Google this because it can't be minus minus unless it is minus minus. Then ammonium chloride. Wait, what? Okay, my friend just texted ammonium chloride. Ammonium chloride they put there as NH4Cl. So I'm not sure about the two negatives. Unless okay, I'm not sure, but let's just continue. Carbonate. Carbonate is CO3 2 minus. Oh, these are all minus. Okay. So I guess the minus, like, I don't know. We just try to make the number of minus the same. So we need 2 ammonium. So bracket NH4 2 CO3. Okay, nitrate is N. Oh, don't get confused with nitrate and ammonia. And is NO3 minus. So it's just NH4NO3. And sulfate, it's NH4SO4. Right? Oh, 2 SO4. Yeah. Yep, so that's the chemical formula. Let's try. Okay, what does my note say? Calcium hydroxide. Calcium hydroxide. CaOH, and then there's 2. Oh, this lime water. Plus what? Ammonium chloride. Okay, ammonium chloride is NH4Cl. Okay. Salt, what is the salt? Okay. Oh wait, no. It's ammonia gas. Okay, ammonia gas is NH3. The symbol, state symbol. Okay, so NH3, then we have 1 hydrogen left. That hydrogen, okay. So it will CaCl. Calcium chloride. I need 2Cl. Right? Yeah, I need 2. Okay, I'll go back wise. And H2O. Okay, wait. And liquid. Okay, CaCl is aqueous. AQ, yeah. Okay, so there's 2 hydrogen, there's 2 oxygen, and then there's one hydrogen, the leftover, right? So in total we have 3 hydrogen and 2 oxygen, and we cannot make H2O because we need the ratio of hydrogen to oxygen. What? Oh man, I reached the end of the page. Okay, wait, I'll just use the other side. Because we need the ratio of hydrogen to oxygen to be 2:1. So it's 2:1, right? And we already have 3 hydrogen. Right. And we only got 1, we got 2 oxygen. So that means we need one more hydrogen, right? If we double the NH4Cl, we can get 1 more hydrogen. We get 1 more hydrogen, right? So we got 4 hydrogen. 4 hydrogen, that means we can make 2 waters. And then the NH3, we can make it into 2. So there you have it. That is chemical property number 2. Okay, there's one more chemical property. I'll just use this side. Oh, okay. It's been 1 hour. Oh man. Okay. Chemical property number 3. It is called. Okay, this one has a name also. It's precipitation. Precipitation. Okay. It is when an alkali reacts with a solution of metal salt. So what is a solution of metal salt? Basically, let's say, okay. Let's see. Okay, let's just dissect what is a metal salt. Metal salt is basically, an example is iron. Iron sulfate. So how do you get iron sulfate? We just add, what is it? To get iron sulfate, we use H2SO4 plus Fe. Then that will give us FeSO4. Right. So that's iron sulfate. Iron sulfate is a metal salt. So it's basically any metal that we reacted with an acid. Okay. Because this part, I'm also, to be honest, I'm not really quite sure, but we move on. We get metal hydroxide. And a salt. Okay, okay, one thing to note, the metal hydroxide, right, it is usually insoluble. Insoluble in what? In water. So then, thus it is produced as a precipitate, a PPT. Okay. So if you've learned qualitative analysis, you've probably learned what is it? NaOH, right? If you want to test for, like, let's say, iron 2 ions, you add NaOH, right? Then you will get a green PPT, right? And it's it's insoluble in excess. So this is basically the reaction. This is like the chemical reaction behind all of that. Which, to be honest, I just realized this. As I'm teaching you right now, I just realized this. So, see, giving you guys tuition is benefiting me also. Okay, let's use the example that we used earlier, the iron 2 sulfate. Okay, so let's say we are given an unknown sample, and that unknown sample is iron 2 sulfate. So we don't know this, we don't know it's iron 2 sulfate. And we know that we add sodium hydroxide. So we add sodium hydroxide, right? What do we get? We get, okay, metal hydroxide. So it's obviously going to be metal. So it's either Fe or Na. Let's just put Fe. So remember this Fe. Oh, there's a 2 plus charge. Fe, then you'll obviously get OH lah. OH2 because OH has okay. Yeah, you figure out on your own lah, but by now you should know FeOH2. Okay, so that is a metal hydroxide because it's a OH is hydroxide, and then we get NaSO4, sodium my S is weird, sulfate, NaSO4, and there you have it. So when we are given an unknown solution and then we add NaOH and then the solution turns green, right? This is the thing that makes it green. Iron hydroxide is what makes it green. Okay, so one more example, since it's a new chemical property. Calcium hydroxide, CaOH. Actually, you know what, we've done calcium hydroxide already. Let's do aqueous ammonia. Okay, aqueous ammonia. Aqueous ammonia is basically ammonium hydroxide. Ammonium is NH4 minus, hydroxide is OH minus, so it is NH4OH. Okay, aqueous ammonia and what? NH4OH plus what, guys? Plus what? Copper 2 nitrate. Copper 2 plus, so it's NO32. Okay, so first we're gonna get metal hydroxide, which is obviously gonna be the Cu, and then Cu is 2 plus, right? So you need bracket OH2 plus ammonium nitrate, so it's gonna be NH4NO3, and ta-da, there you have it, precipitation. Okay, I'm gonna take another break. You can take your break whenever you guys want. Okay. So we have now finished the chemical properties of acids and bases. Now, let's go back to, oh my gosh. Okay, let's go back over here. Bases, right? So over here, we've mentioned that bases are basically metal oxides and or hydroxides. So previously, we have focused in what's in this circle. I'm gonna use previously we have focused what's in this circle. Now let's focus what's in the rest of the big circle. We're gonna focus on that. So go back to the basics. A base is a metal oxide or hydroxides. So oxides. What are oxides? Okay. Oxides are formed when elements are burned in which substance? In oxygen. Oxides are formed when elements are burned in oxygen. So for example, if sulfur is burned in oxygen, sulfur, then we would have sulfur oxide. And if sodium burns in water, we get sodium oxide. But there's one substance, when it burns in oxygen, it gives something else, that is hydrogen. When hydrogen burns in oxygen, what do we get? That's right, we get water, because it's H2O. However, there's also carbon. If carbon burns in air, there can be two things. There's carbon dioxide, and there's also carbon monoxide. So these are all examples of oxides. Okay, so again, more info on oxides. Okay, I'm just gonna add it over here. Oxides are binary compounds. So you may be thinking, what are binary compounds? Especially what is binary? Okay, binary compounds, that means made up of two elements only. And for oxides, they are binary compounds which comprises of only oxygen and another element. So oxides are basically one element and oxygen, and it's only these two elements. There cannot be hydrogen, there cannot be carbon, there cannot be anything else. It's something and O. Okay, under oxides there are four types. Four types of, I want to make it nice. No, the O is not nice. Four types of oxides. Okay, what are the four types? They are acidic, basic, neutral, and a familiar word, amphoteric. Okay, let's just dive into them. Okay, so we know how in the periodic table there's metals and non-metals. Metals metal oxides, they can either create basic oxides, or they can create amphoteric oxides. However, for non-metals, they can fall under acidic oxides or basic or sorry neutral oxides. Okay, so now we have broken them into smaller pieces. Let's focus on one piece one by one. So basic oxides. Basic oxides are basically oxides of all metals. Oh my god, the F. Oxides of metals. Regardless, it doesn't matter what metals they are. It's anything but three. Oh my gosh. It's anything but three metals, and these three metals I'll cover them later, like in a few minutes. Okay, something to note about about basic oxides: they react with acids but not alkali. Okay, some examples. Na2O, so that's sodium oxide. Then there's MgO, that's magnesium oxide. There's CaO, calcium oxide, and there's copper 2 oxide. So these are some examples. Okay, so now amphoteric oxides. Let's go all the way down here. Okay, amphoteric oxides, they are oxides of three elements, three metals to be specific. Hold on, someone's texting me. Let me check. Oh. Okay, never mind. Okay, oxides of lead, aluminium, and zinc. Okay, so something to note, they react with acids and alkalis. So the chemical formula would be aluminium oxide, which is Al2O3, zinc oxide, which is just ZNO. This is my favorite chemical formula, by the way. It's just ZNO. It's so like cool. Then it's lead 2 oxide. Oh, it's not just lead, it's lead 2. Lead 2, which is PbO. Okay, acidic oxides. These are oxides of, similarly to basic oxides, oxides of non-metals. We generally do not discriminate. It can be any non-metal. So we have, oh wait, so this one reacts with alkali but not acids. Wait, hold on. Someone is spamming me on TikTok. They're sending me messages. Okay, they react with alkali but not acid. Some examples are sulfur dioxide, is SO2, carbon dioxide, CO2, phosphorus is PH, if I'm not wrong, PHO, and nitrogen dioxide, NO2. Okay, and then last but not least, neutral oxides. So neutral oxides are usually monoxides of non-metals. So monoxides, what are they? Mono means one. So that means there's only one oxygen in the compound formula. So, and the chemical property, they do not react with alkali and acids. Some examples are the one that we covered, carbon monoxide. There's also water, because again it only has one oxygen, and nitrogen monoxide, no. So done, we have covered oxides. Okay, for amphoteric oxides, how I remember the three metals, right? Okay, it's gonna be very embarrassing, but anything for your education. So there's lead, Zeppelin. That's how I remember Led Zeppelin, because wait, lead is obviously referring to lead, then the Z refers to the zinc, and then the L is in aluminium. Aluminium. So that's how I remember Led Zeppelin. The three metals that make up amphoteric oxides. So those are oxides. Okay, I'm gonna take one more break, and then we're gonna cover the very last part of acids and bases, which won't take more than 10 minutes lah. Okay, I'm gonna take a 2 minutes break. Okay, I'm back. Okay. Let's go to the pH level of the chapter now. Okay. So we have the pH scale. Okay, the pH scale, what does it do? It indicates whether a substance is acidic, oh my god, alkaline, or alkaline or neutral. Okay, so how does it indicate? If the pH is below 7, then it is acidic. If it's over 7, then it is alkaline. Oh my gosh. If it's directly 7, then it is neutral. Did I say directly? If it's die 7, then it's neutral. Did I say I keep using the wrong terms. Okay, so we can also use a universal indicator. Okay. Okay, so all these numbers, they are the numbers on the pH scale. OMG. Okay, a universal indicator is basically a substance that it will change color depending on the pH level. Okay, so now let's use a highlighter. If the pH level is between 1 and 2, the universal indicator will turn red. If it's from 3 to 4, it should be orange. It will turn orange. Then 5 to 6, 5 to 6 it will turn yellow. Then from 7, wait, this is not green. Okay, from 7 to about 10, 7 to 9, 10 ish, it will stay green. And then from 10 to 12, it will be blue. And 12 onwards, 12 until purple. Actually, I should use this blue because it's more accurate. Oh, it will be purple. So this is the rainbow of acids and alkali. So some examples are, if I'm not wrong, nitric acid is over here. Okay, wait, let me refer to mine. Yeah. Then vinegar. Pure water should be between 6 and 7. Aqueous ammonia will be between 11 and 10. And finally, sodium hydroxide will be at the very end. Okay, so what are some uses of acids? Wait, is it just acids? Yeah, it's only just acids. Uses of acids, okay. Sulfuric acid. It is used in detergent. What else? Fertilizer. And car batteries. For hydro hydrochloric acid. It is used in leather processing and cleaning of metals. And for ethanoic acid, it is used in vinegar to preserve food like pickles, as well as making adhesives. Okay, those are the uses of acids. Not sure if they will be tested, but additional info, I guess. Okay, so why is pH so important? Right, it's like, okay, so what if it's an acid or an alkali? Okay, it's important in controlling the pH levels of soil, because this affects the growth of plants. Yeah. How does it affect? Well, most plants, they grow best at around neutral or slightly acidic. More specifically, it's like 6 to 7, the pH level. And plants will not grow in soils that are too acidic. Because plants have feelings. So acidic soils, they can be treated with bases. Some examples are calcium oxide / hydroxide. Okay, calcium hydroxide, this is important. Calcium oxide, calcium hydroxide. Calcium oxide is quicklime. Whereas hydroxide is slate. Lime. This process is called liming. And there you have it. Importance of pH. And with that, I end my lesson. Okay. You know what, I'm just gonna end it here. If you have any questions, you can rewatch the video to understand, or you can comment down below in the comment section and ask me questions. Don't forget to like, share, subscribe. I will be posting neutralization and salts as well as writing balance equations later. Okay, bye bye.